Hi everyone, and welcome back to another episode of the Learning FreeCAD for Beginners, where we teach the fundamentals of FreeCAD in a practical way by learning different workflows and how to apply them to your projects. In this episode, we're going to be using a master sketch workflow, allowing us to change parts of this sketch to adapt our model to different dimensions. Our model is fully parametric, and this master sketch allows the loft, the revolve, and any additional features that have been added to the model to reconfigure. Now we're continuing from the previous video where we was lofting objects, and we're going to be lofting in the part design, and we're going to create this model. Don't worry if you haven't watched that video, we're going to be taking you through the whole process in this video anyway. We're going to be following a master sketch workflow. We'll create a master sketch which we control in part design objects made with sketches and actions. The dimensions of the sketches will be controlled by formulas or expressions, which will be referenced back to the original master sketch. Any changes in the master sketch will reflect down to the underlying geometry and the model itself. So I hope you're enjoying this series, hope you're finding it useful, and let's have a look at this workflow. If you like what you're seeing, please subscribe to the site. I also have a Ko-Fi or a coffee site that you can donate to if you so desire, and that's at ko-fi.com/MANG0. I also run a Patreon where you can subscribe and get extra content, and that's at www.patreon.com/MangoJellySolutions. Any money that's kindly donated will be used to expand the channel. For this tutorial, we're in FreeCAD and create a new document. I'm going to be using the part design. So I'm in the part design and I'm going to create a body. I'm going to create a sketch. Now this sketch is going to be basically the roughing out of the object. It's going to be our master sketch, and we're going to be using that to transfer sizes and dimensions to the actual model. So we're going to go along the XZ plane. I've decided that I want to place it along there, and I'm looking basically at the profile of the model. And I'm going to use some geometry in here. So we're going to be using a line for the base. So this is going to be the base, this line here. And we're going to place another line here. So we'll set some radius along here. This will be how high we want this base, the thickness of the base. I'm going to hit escape to get our mouse pointer back, and again. And I'm going to place some constraints in here. So I'm going to place a length constraint. And we're going to set this one to about 40 millimeters. Hit OK. And these two are going to be equal. Let's set a height here. And this is going to be about 6 millimeters. And now we want the height of our loft. So I'm going to use some geometry for that as well. So I'm going to place a line in here and set the length of that. So I'm just roughing out the object. That means I know I'm at the right scale down here. Let's set some height quickly. So about 70 millimeters. And it also gives me an idea of what the object's going to look like in a very rudimentary form. I'm going to have a circle here. This is going to be a sphere that I'm going to use. I'm going to set the radius of this sphere as well. Set the radius, and we'll set that to 15 millimeters. And OK that. So what I'm going to do is actually loft from this point to here, and the same with this one. So I need to figure out where I want the loft to actually stop. So I'm going to have it stopping in the middle here, and I'm going to place a line, and this is going to be the size, well, the radius of this loft. So we're going to come out, let's come out this side so it's out of the way. And set a size in here, and set this will be a length, and we're going to say this is around 10 millimeters. So we're going to loft into this point. So our top section, our top profile will be of a radius of 10 millimeters. Now I think that's all the geometry we need. Actually, we do need the arc. So I'm going to add an extension to this base here. So we're going to come out to about here. Going over constraint, let's click the constraint and hit delete. Hit escape and set some length in here using the length, and set this one to around about 15 millimeters. I'm not going to bother with this side, but we've got all those in there. Let's bring these down. Now what I'm going to do is start naming these. So each of these constraints are going to have a name, and that will allow me to reference them from the part design. So let's start from here. So this is going to be the base thickness. So come into name and call it base thickness. Notice that I've used an uppercase B and an uppercase T. This matters. So when we're referencing these outside, then we need to take into account of that. So we've done that one. This one's going to be base profile radius. And then we've got this one here, the top profile radius. And finally, the sphere radius. So what I'm going to do is recreate basically this object in 3D. I'm going to be working from the bottom up. So first we'll create the profile of the revolve that goes in here, and then we're going to start lofting up to the sphere. Let's hit close. And we've got our master sketch. Let's name it. So come in and rename to master sketch. Now this master sketch will be the reference for all of the geometry, and we're going to be using the formula field or the expression editor to allow us to do this. So let's create our first piece of geometry, which is going to be our revolve. Make sure nothing's selected and create a sketch. Now straight away we're going to use the master sketch and see that we need to go along the XZ plane. Our master sketch is shown through, and we can start placing in our revolve. I'm not going to actually pull in any of this geometry. So what I'm going to do is start adding in lines into this. So I'm going to start creating 2 lines. So coming in here, 1 and 2, like so. Now attach my master sketch to this line. I'm just going to use the underneath this line for this. So I've placed that there because I want center, say here. It doesn't matter, but we could have moved this up and done this. I've added that geometry there, and I'm going to add a length in here. So this one here. So we've gone over constraints, click the redundant constraint and hit delete, and start getting some lengths in here. So I'm going to use the height first and click on this one. Now we'll come into this button at the end, which is the expression editor. Click on it, and we start typing in the name of the sketch. Now you know we renamed it, so we start typing in capital M A S, and we got master sketch there. So click on that. We can see there's a dot added. That's important. That means I can start typing in uppercase C, O, and we get the constraints. Click that and hit a dot. Now this is where we have to remember what we call them. So I know this is called base thickness of 6 millimeters, and hit OK. If I hit OK now, what will happen is if I hit escape to get the mouse pointer back, the height will be added. It's in orange. That means that it's external geometry that this is referencing. And this will show up down here as well. So we come down to the bottom, and if we bring it out to see all the constraints, we can see we've got the constraint 7 there with 6 millimeter, and it's got a formula on the end, this one here. Let's just put that back. So we need to do the same with all the rest. So let's take this one and place a length in here and click the formula editor. And it's same as master sketch dot constraints dot base profile radius. That's 40 millimeters. Hit OK and OK again, and that one's in there now. Come in, we can see that this isn't constrained to here, so I'm going to click on those two and put those coincident to each other. We have a constraint, click on the constraint, we see that constraint there, point on the line constraint, and that's hit delete. So that's in place. So we've started creating our shape. Now we need an arc. So I'm going to pull in our arc. I'm going to use endpoint and rim point. Click on this one and come into about here on this line and just bring this arc around. I'm going to make sure, hit escape, make sure that these two, so this point here, these 2 points are in line, and place another line to connect up with this one. It's a coincident constraint to that center point there, and delete any redundant constraints. Now we've still got on the master sketch this one here, so the length here, which is just 15 millimeters. I didn't actually name this one, so let's give for this one a name, and I'll just call this one overhang, something like that. I'm not quite sure what to call this one, so I'm going to just call it that for the time being, and hit close and come back into this sketch and set lengthen here. Click on the formula and type in master sketch dot. Just press the down arrow to get to there. Constraints dot and overhang, and hit OK. So now we've got that one in there. We're just going to make this one and this one tangent to each other and hit OK. So we've got a fully constrained sketch. I can hit close, select that sketch, and come up to the part design, come down to create a additive feature and revolve that the full 360 and hit OK. So now we've got the start of our object. So we've got the main revolve. So now I'm going to tackle Loft by clicking on this face and creating a sketch. But we're going to create 2 profiles that are the same but different radiuses. So we're going to use this radius here and this one. So we know the length here. You can do this in a certain way because I want to duplicate the sketch. So let's create a sketch on that face. And what I would normally do is just pull in this circle and use that to attach a polyline to. So I'll just pull in this circle and I will create basically a profile that's basically like this, using this circle and using a point on object constraint to constrain these lines. I can't do that because if I try to pull in this edge, when I duplicate it, then I have to disconnect this edge to resize the whole lot. So I'm going to use a circle in here, like so, and then I'm going to pull in this edge. But I'm not going to connect out just yet, so I'm going to pull in this edge, and I'm going to come in and start sketching upon this circle. So using the polyline, and we're going to auto constrain to the circle and create a straight line at the top, and I'm creating this cross. So we're going to go straight line, come across, straight line, and I should actually do it quite roughly. So as long as it's all constrained there, and show you a quick tip of getting these straight. So probably already know this, but the constraints, let's hit escape to get the mouse pointer back. If I wanted to constrain all of these, I've got multiple horizontal lines here. So there's 2 ways of doing this, like clicking them all the horizontal ones, and adding a horizontal constraint in there, or clicking the horizontal constraint first and then selecting the lines one by one, because we've still got the tool active. And vertical constraints, which are these, this one and this one. And now we need to create some inline constraints. So these 2 are in line, and these 2 need to be in line as well. And using the equality, so we take this one and make those equal. And this one isn't vertical, so let's add a vertical constraint there. So we've got movement like so, but we need to make sure that these 2 are in line as well. And let's have a look, see what we've got. So we've got a nice cross in there. Let's take this circle and make it construction geometry. So that's blue now. And then take this circle and this circle, make those equal. So although we pulled in the external geometry, I've made the construction geometry equal to the external geometry. And we'll see the reasons why in a minute. And we'll take this line and put some length in there, which will constrain it. And we'll set that to around about 12 millimeters. That's good. So we've got that one there. Let's hit close. We've got this cross in here. I'm going to duplicate that sketch. So click on the sketch, come out to edit and duplicate selected object. Now it's going to duplicate all of them. So we need to take the last one off. That'll leave our sketch still selected there and hit OK. We've got our duplicated sketch. And if I right click and rename this and change it to top profile, and the same with the other one to bottom profile. I can now take the top profile and set some height. So looking back at the master sketch, we know we've got a height in here. So this is going to be the loft height. We haven't named that yet. So let's come in and set this one to loft height. Hit enter. Come in close and come down to the top profile, and we want to come into the attachment and the position. So this one here, span out and look at the Z and use a formula editor on the end and using the master sketch dot constraints dot loft height. So we've got 70 millimeters in there and hit OK and click off. And that's placed that there. So directly upon there. Now, if we've changed this and we actually started this revolve on this point, then we would have to minus this height off. So this height here, but we didn't, so we're okay. At the moment, this profile is way too big. So let's come into that top profile and adjust that. Now, if we look at this, we've got blue circle here. Come over to the left-hand side and look at what we've imported. So we've got all the elements in here, and we've got this element here, number 14. So it's got a purple dot in the middle. Let's come over to the top and drop down this mode and look for external. We see that's external geometry, that one there. That is the external geometry from here. So we need to delete that. So just right click and delete. So that's gone now. So we can actually move this one to a different radius. Now remember, we set the radius for this one in our master sketch. So we close and have a look at our master sketch. We've got this one here. So come into the master sketch. If I come down to constraints, I can actually see all those constraints in the master sketch. So I've got them all named here. So this is a quick way of figuring out whereabouts those constraints are. So we're looking at the top profile radius, and I've realized I've spelled sphere wrong there, but that's okay. It's placed spaces in there, but remember we haven't got spaces. So that's come into that top profile and set the radius of this. Let's give ourselves some space and come up to the radius using the formula editor and master sketch dot constraints dot top profile radius 15 mil. Hit OK, hit OK again. We've changed that. Now I'm going to change also this length here. So at the moment that's 12 millimeters. I could use another formula and go back to the original base profile and say divide this by 2, so we have 6 mil, but we can do that another time. So I'm just going to add that one there. So remember, we created construction geometry and then sketched that cross in there and then attached the construction geometry to the external geometry. If we would have just created the cross inside the external geometry and attached it to that external geometry, then deleting that external geometry, we would have lost the constraints against that cross, and we would have to create a new circle, change that to construction mode, and then reattach each of those points with point on line constraint around the outside. And this is why we did this first with the construction geometry, and then made the diameter of that construction geometry equal to the external geometry that we pulled in. Saved us a lot of time. Now be wary, because when we loft here, we're probably going to create a non-planar face, which we're going to have to attach a sketch to, which we're going to go through in a moment. Let's hit close. Now let's create our loft. So we've got the bottom and the top profile. Come up to part design, create additive feature, and additive loft. It's going to ask you what profile we need to use. So I'm going to select the bottom profile, this one here, the one that's attached to this object, and hit OK. Now we need to add a section. So add section, come in and select one of the edges of this profile. We've lofted to that. If you pick a vertex, it will be lofted to a point to that vertex, which we don't want. Let's hit OK. Now we've got our loft. If I decide that, well, this loft is too near, I can come back to the master sketch and change the size of this. So we've got 70 millimeters here. If you can't click on it, then just roll over it again and click. There we go. Double click, and I'm going to set this to 80 mil. Let's move that up. If I hit close, everything will recompute, and we're back like that. Let's add the sphere in here. So to do that, I'm going to make sure I've clicked off, and we're going to use something that we haven't used yet, and that's part design, create an additive primitive. And these are all the additive primitives here. So we've got additive box, additive torus, etc. And we're after the additive sphere. This will add the sphere to the screen, but we can't see it at the moment because it's actually embedded at the center of origin, which is inside here. Let's come in and change the radius of the sphere. So let's set it to 20, and you'll see it pop out the bottom there. That's good. We now need to set where it's going to sit. So you can see this attachment at the moment it's saying selecting. That means that we can select something. If you're saying reference one or anything else, make sure we click on that button. And we're going to select that top face, and that will move that sphere to that top face, like so. And we can get an idea of the radius of what we want that sphere to be. So I'm going to say 30, click off, and that's looking about right. Let's maybe go to 25. There we go. So it should be about 25. So we can come in and use the formula and reference this back to our master sketch. We've got constraint in there. It's for the sphere that's actually spelled incorrectly. So dot sphere radius without the E, and let's hit OK. So I need to change that sphere radius because it's only 10 at the moment. So let's OK that and come back into the master sketch and change this sphere radius. So double click that, and you can see I've got sphere radius there, 25, and change the name to an E. So what do you think might happen? Let's hit OK and hit close. That sphere has changed size. So if I double click on that sphere, or actually come down into the data view, we've got the radius here. So click on it, click on the formula editor on the end, and you can see we've got sphere radius spelled correctly. It's almost like I've done that on purpose. So you can see how editing the name of the constraint gets updated in your formula as well. So let's hit OK. And we now got this object here. I want to take a section out of this. So I want to follow this face here, going forward and intersecting this sphere. Now there's two ways of doing this. We can add a sketch to this face. So if I add a sketch, it's going to complain that it's not a planar face. That means we don't have all the vertices of that face on the same plane. So let's hit OK. We can't create a sketch upon there. Now, there's two things that we can do. One way, which is often frowned upon, but it has its benefits, is to use something called a datum plane. The reason why it's frowned upon is it takes more computer power to actually process this. Let me show you how it works. So we're going to use the datum plane on this face. And all this does, it creates another plane that's attached to this face. So come in, use the datum plane. You can see we've got that plane that's been placed upon that face. Let's hit OK. We can sketch upon this plane now. So click the plane, top of it, and create a sketch. Now, word of warning, and it's done exactly what I thought it might do. It's placed me on the wrong side of the object. So we're looking at the rear. So to fix that, what we need to do is just close, and there's an option on the sketch to map reverse. There's also the same option on the datum plane, so we've got map reverse there. We can use either or. Let's use it on the sketch. Map reverse, set that to true, click off, and what will happen if we double click on that sketch, it's now on the correct side. So it's on the other side now, and we're looking down on that. If I hit the section view or come to sketch view section, it slices through there. So you can see it's slicing right through there. And we can decide what to bring in, what geometry to bring in. I want to remove that face like that. So we've got something to place another feature upon. Trouble is, I'm not going to be able to get to any of the geometry underneath. If I try to hover over some of this, you can see some of it's coming through, others isn't. So how do we get around that? Well, it's as simple as hitting the right mouse button to get the pointer back, come over to the model and hide it in the datum plane. And coming back to that sketch. And now when we bring in the geometry, let's bring in this point. Zoom in, see if we can get it, that point here, this vertex. And also there's a vertex. If we look at the seam, this seam will be running from the middle. So we can utilize that vertex as well. Let's bring in that vertex. If you can't get the vertex, you can get the line. So this gives me a way of sectioning through this along this face. Got the two vertices imported, and that's create a circle that's on this line and bring it around. And we're going to attach to this vertex, point and line constraint, and also we're going to attach to the top one as well. Click the right mouse button, take the top vertex, or the top point, and this circle, and the point and line constraint. That's fully constrained. And we can pocket this. Now, you may have noticed this, that if we pocket, we're going to go downwards. We just use a reverse pocket. There's an option on the pocket. So clicking on the pocket, we'll see that's gone downwards like so. And if we increase this, you can see it's going down even further. So if we come to reverse and click off, at the moment it's done nothing. So let's change this to something like through all, and that's gone all the way up there. If you have problems and it looks a bit funky, it doesn't look quite right, then just swap these over to first and then through all, and it will refresh correctly. Now we've done that, let's hit OK. We've now basically finished our object. We can create something in here that's, say, another sketch, and let's add a circle in here, and this can be, say, another pocket in here, so we can pocket that. Let's just go for the defaults. So we created this whole thing from master sketch except for this part. What does that mean? Well, we can use the master sketch and change the dimensions in here. Before I do that, let's save this. And if we change the dimensions, what will happen, let's change, say, the radius of the loft, which is this one here, and change the radius to say 30. So let's bring in this in to here. And we've got 15 millimeters here, so let's send this out to 20. To change the thickness to 5 and hit close. We've now changed everything on there. We've got no errors and everything's recomputed. Now remembering what I was saying back to the datum plane. This is where the datum plane comes in handy. Because it's attached to that face, it will move and flow with this face. So it will change the angle as this face changes angle. And hit close. You can see we've got this loft and this datum plane's added to this face, and we've got a different angle there. We've got a different angle on the top. So that datum plane has flowed with that. What's normally advised if you don't want to use a datum plane is that we actually use a sketch and angle it across here. But the problem is that we're not going to get this type of flow with that sketch unless we do something quite clever with that sketch and change the angle and connect it up to a reference angle in here. And there's ways of doing that, but I'm not going to go into it for this tutorial. I'm going to leave that for another tutorial. We use something called a reference geometry in there, so we can actually set geometry to a reference angle. For instance, if I come into the master sketch, so this 20 millimeters here, if I double click that and set that to reference, that means if I hit OK, that has become not constrained. So you can see that's not constrained there. And we can change that to whatever we want. So we could have an angle on here. We could connect up the angle, say, to here along that loft. So it follows that loft, and place a reference angle in there and incorporate that into our geometry. So from this lesson, you've learned how to control a part design model through a master sketch, and also learnt about formulas or the expression editor. In our next video, we're going to be looking at hidden attachments in objects. So for instance, if I look at this object, if I wanted to attach this to a wall without showing, say, some holes that go around the outside here that have screws through, then I need to make a hidden attachment in the back. Now this could be some kind of slot or bayonet attachment, and we're going to be looking how to create that feature in here, because we need to know how to model internal features. So I want to make, say, a groove in here, but have the groove enclosed slightly so it will latch on to any screw or bolt that we have attached to our wall that we can just twist this onto. We won't be recreating the same model again. We can just create this on a basic disc shape, but we can attach this to that attachment for our end example. So I hope you've been enjoying these videos, and I hope to see you again in the next one. If you like what you're seeing, please subscribe to the site. I also have a Ko-Fi or a Ko-Fi site that you can donate to if you so desire, and that's at ko-fi.com/MANG0. I also run a Patreon where you can subscribe and get extra content, and that's at www.patreon.com/MangoJellySolutions. Any money that's kindly donated will be used to expand the channel. Thanks a lot for watching and subscribing, and I'll see you again soon.